All right, so this relates to problem number 74, which is about these really destructive gypsy moths. And however many egg masses the biologist counts or the forester counts in the fall, and then relates that to what percent of the tree is defoliated in the spring, meaning what percent has been de-leafed. And so we can see that the numbers start getting pretty extreme. And so one of the things that I will recommend doing here right away, because X and Y in the table are not actually labeled, but we want to get organized with the information that we're given in the problem. Okay, namely, this is the number of egg masses, which honestly to me sounds gross, but there it is. And this is the percent defoliation. Okay, and this is the experimental data. It's not stated explicitly in the problem, but we can infer it. How? Because then we're subsequently given a model for the data, and then we're asked to calculate the model values and see and compare them. And so what we're going to have to do is we will start with this table, but we're going to need to add another row, which is model percent predicted. So this happens very frequently when we are doing any kind of data collection. We can create a mathematical model that attempts to match the data, but the reality is that the real world rarely perfectly matches whatever our mathematical formulas are. And so we can compare the percent defoliation that the model predicts against the actual defoliation that was observed by the scientist. In order to do that, then we're going to need to plug the formula that's given into the calculator. Okay, so I want to make a really important point here. And again, part of this depends on how your calculator is set up. But if we are given y equals 300 divided by 1 plus 17 e to the negative 0.065x. In order to communicate reliably with our calculator, we're going to have to introduce a couple of sets of parentheses. Some calculators will let you set up a fraction that looks like this and will allow you to format the exponent. But if you have a TI-83 calculator like I have, we're going to have to communicate to the calculator which things are grouped together. And we're going to do it as follows. We're going to put a set of parentheses around the denominator. Otherwise, the calculator is just going to divide 300 by 1, and then next, it's going to add all this stuff. But we don't want it to do that. We want it to divide 300 by everything that's down here. The way that we indicate that is through parentheses. Likewise, we're going to need to let it know that everything that is up here is part of the exponent. Otherwise, it's going to take e to the negative 0.065 and then multiply by whatever x is. But we don't want it to do that. So the parentheses then end up being super important. But now we can go ahead and plug it in. So let's just go ahead and plug in the value that's in the middle. I'm not going to do them all. You can do the rest. But let's go ahead and do 300 and in fact the book doesn't even have these parentheses, so I just kind of added those while I was writing it out of force of habit. But we just need these two sets of parentheses around the denominator and around the exponent. So we've got 300 divided by, and now I'm going to do open parentheses. So we've got 300 divided by 1 plus 17 e to the, and in fact, it's going to automatically give me another set of parentheses. So it's already opening up the second set of parentheses. Then this is going to be negative, not minus. Remember, the negative key is down here. So negative 0.065 times 50, close exponent parentheses, close denominator parentheses. All right, and then we can go ahead and hit enter. And I am getting a number when I enter it that doesn't make sense on my first pass. I'm getting 180. For me, that's not passing the smell test because it doesn't make sense that 180% of the tree is defoliated. I can see. So like I said, what percent of errors just come from doing the wrong problem? About 50%. So you guys have probably been screaming at home the whole time, Miss Ferris, it's not 1, it's a 3. Okay, well, so hopefully this is satisfying. I'm going to erase this 1. I'm going to replace it with a 3. Here's a neat little trick. I'm going to go to second, enter, and it's going to re-give me my equation, and I can actually just scroll up and write over that 1 with a 3. Okay, I hope this process is helpful because we've always got to sort of be applying the smell test. Does what I'm getting actually make sense in the context of the problem? 180% did not make sense. And so then I just stopped immediately and went back, and the first thing I checked was, am I doing the right problem? And in this case, the answer was no. I was doing the wrong problem. But once I identified the issue, then it was easy to go back and fix. Okay, so now I go ahead and hit enter, and I find that I've got 81.98%, or basically 82%. So 81% was observed, 82% is what the model predicts. They're similar, but they're not exactly the same. And that's kind of the best that we can hope for from a good mathematical model. That it will get us close to reality, but it's probably not going to exactly reproduce reality. Okay, so here's our 81, there's our 82. You can go ahead and complete the table by this process. Okay, so if we're going to estimate the percent of defoliation if 36 egg masses are found, well, we don't have 36 on the table. So 36 is in here somewhere. I suppose we could try to figure it out. Like, how far away is 36 from 25 versus 50? But the reality is this a linear function? No, it's exponential, which means it's going to be more difficult to just sort of eyeball and predict. And so the easiest thing to do, one, if you've graphed it on your graphing utility, you can use the trace function. But the other thing, of course, that you can do is we just did 50, but instead of plugging in 50 here, you can just plug in 36 and calculate. Then what you're asked to do is you're asked to estimate how many egg masses there are. If it's 30, what did it say? Oh no, not 30, 2/3. So if it's 67% defoliated, how many egg masses is that? Well, we haven't learned how to do the opposite operation of exponential functions yet. So here, tracing it on the graph is definitely going to be your best bet. You're looking for where your y is about 67, and then you're backing up to the x to see what x produces that 67%. All right, so hopefully that's helpful on problem number 74. Good luck.